Hello everyone, I'm Aravinda Fernando, your moderator for the next two sessions. Welcome you all after the lunch break for the next session on taming non-determinism with dependency injection, where you would be able to learn about dependency injection, which is a way to tame non-determinism in code and take back control over your code. As a bonus, it will also make writing tests much easier. Get the maximum out of the sessions and clear all your doubts with Mr. Haki Benita, the speaker for the session. Mr. Haki Benita is a software developer and a technical lead. He takes a special interest in databases, web development, software design, and performance tuning. Haki writes about development and performance on his website, hakibenita.com. So let me welcome Mr. Haki to demonstrate how to implement dependency injection in Python and how to simplify your tests. The stage is yours, sir.
Thank you very much. Hi, everyone. I'm so happy to be here in PyCon, Sri Lanka. I think it's really great how communities can form around something like Python. So as promised, we are going to talk about how to tame non-determinism with dependency injection in Python. So before we start, briefly about myself, the things that you haven't heard so far. So I'm leading the development of a large ticketing platform, which is mostly developed using open source tools such as Linux, Python, Postgres, Django, TypeScript, and so on. And I write a lot about databases and all of the things that I'm working about in my website. So who is this talk for? First of all, if you're not sure what non-determinism even means, then hopefully by the time we end this talk, you will know what non-determinism means and how to identify it. If you do know what it means, then maybe you're not aware of why it's even a challenge. So I'm going to hopefully explain to you why this is a challenge and offer a way for you to handle non-determinism. Okay, so let's begin. Now, my promise to you in this talk, I'm not going to show you any libraries, packages, or dependencies. We are going to talk about a pattern that you can implement in your code. So this is basically just Python, okay? It's nothing fancy. You don't have to pip install anything in order to implement dependency injection. In fact, it's not even Python. You can implement the concepts that I'm going to show you in any project you are working on, regardless of the language that you chose to work with. I want to start with an interview question that I like to ask candidates. And it looks like a simple function. It looks like a simple question, but stay with me. So I want you to think about how you would write a function that returns tomorrow's date. Okay, so if today is the 22nd of February, the outcome of the function should be the 23rd. So when I ask people this question, usually what I get is something like that. Okay, you have a function called tomorrow. It returns an instance of daytime date. And to implement the function, you get today's date from the daytime model, and you add one day to the result, right? So this is simple. This is very straightforward. Nothing fancy about this function. But there is a follow-up question, okay? It doesn't end here. There is a follow-up question, and that's the follow-up question. How would you test this function? So you have a function that returns tomorrow's date. And now I'm asking you, write a test for this function to make sure that it actually works as expected. So take a second and think about how would you test a function that returns tomorrow's date. Now, when I ask people this question, I get a variety of answers. So let's see some of these answers. So the first thing that you might think about doing is you call this function and then you compare it to some date. Okay? So if we are in the 21st of February, if I execute this function, I get this date. And this is how I know that the function is working as expected. Now, the problem here is that this will pass today, but it will fail on any other day. So if I have this test in my test suite and I push this, it might work today, but tomorrow when someone will execute this test, it will fail. So this is not a good test. This is what's called a flaky test. So another attempt to test this function would be to actually repeat the implementation, right? So you say the expected outcome of this function tomorrow is today's date plus 1. So this is basically how the function is implemented. Now, this might work, but part of the reason that we want to test this function in the first place is that we want to test different special cases, like would this function work on cross year, for example, on the 30 and 31st of December? Would this function work as expected on leap years, like the 28th of February? Okay, so using this method of testing does not provide me a way of testing edge cases. So if you've worked with Python long enough, you probably heard about patching. So what you can try to do next, if you want to try and test this function and also test different edge cases, you can try and use the mock model from the unit test package, and you can try to patch daytime day to day, which is what we use internally in our function to get today's date. And you can try to patch it and actually make it return a predetermined date, in this case 1st of January 2020. And this way you can test, hopefully you can test the outcome of this function. But if you try to do that, you are going to get this exception, which says that you can set attributes of built-in extensions like daytime date because it is implemented in C, so you can patch it with Python. So that's a no-go. But just like everything in Python, there are third-party libraries and packages that you can use. And just to name some of them, you have freeze time, leap fake time, and time machine that has a very similar API to what we just saw. You can use this decorator. All of them work roughly the same way. And you can patch the outcome of daytime to day. And now you can test this function with various edge cases and so on. The downside to this approach is that now you introduced a dependency into your project. Now, I'm not going to go into why dependencies can sometimes be a problem, but just imagine that you now want to upgrade your Python version, you want to upgrade some framework, and now this package does not support this version of Python. So now you are stuck because of some dependency. So usually I like to avoid dependencies. So we took 4 attempts at testing this function, but why is this so hard? And let me just remind you, this is just a talk, and this is just a simple function. I'm quite confident that your code is much more complicated than that. So how come this very, very simple function is so difficult to test? And the reason that it's so difficult is because we have an element inside our function, in this case, daytime to date, that we don't control the outcome of. We don't have any control over the outcome of this function, so we are unable to test the function tomorrow. This is why it's so hard. So this is a good time to talk about what exactly non-determinism means. Okay, so in order to understand what non-determinism means, we need to understand what a deterministic function is. So a deterministic function is a function that when you give it the same inputs, will always return the same outputs. So the simplest example is a function called add that accepts 2 arguments, in this case A and B, and returns A plus B. the result of A plus B. So we can see that every time we call add with 1 and 2, we get 3 because 1 plus 2 is 3. So the function add is deterministic. Okay? Every time we send arguments 1 and 2 to the function add, we are going to get 3. So this function is deterministic. Now, let's look at our daytime now function and see what it looks like. Every time we execute the function daytime now, we are getting a different result, right? Because this function returns the current daytime. So if we wait a second and execute it again, we are going to get a different number of seconds, a different number of minutes, days, and so on. So the function daytime now, is not deterministic because whenever I execute this function with the same arguments, I'm going to get different outcomes. So let's take a look at a few more examples of what non-deterministic function looks like. So take a look at this function. We have a function called addJitter. This function accepts an argument n and adds some random jitter to the number. Is this function deterministic? Take a second, think about it. Is this function deterministic? Will I get the same outcome every time I execute addJitter with the same value of n? So let's try it. And if I call addJitter 3 times with the same argument 1, I'm going to get different outcomes. Why? Because the function random is not deterministic. Every time I execute this function, I'm going to get a different outcome. So the presence of random inside the function addJitter made the function addJitter non-deterministic. Let's take a look at another example. This time I have a function called inc that accepts some argument, an integer argument, and increments a global counter by this argument. Okay, so is this function deterministic? Take a second, think about it. If I execute increment with the argument, for example, 1, if I execute it several times, am I going to get the same outcome? And the answer is no. This result of this function depends on some global variable, or in other words, a mutatable global state. So every time I execute the function inc with the same argument, I'm going to get the current value of the global variable. So this function is also not deterministic. Another example that is very common in a lot of Python projects is accessing the database. So let's take an example. We have a function called getUsername, accepts the ID of a user, opens a connection to the database, issues an SQL command to fetch the username of this user. And then if the user is not found in the database, we return none. Otherwise, we return the username. So is this function deterministic? Am I going to get the same username every time I execute this function? Even if you imagine that the username cannot change. Let's take a look. So let's say that username, the username for user 1 is Haki. So now I go to the database and I delete the record for Haki. I delete the user Haki. And then I execute the function getUsername again with the same argument 1, but this time I got none because the user is not found in the database. So this function is also not deterministic. Just like the previous example with the global counter, this also depends on some mutable global state, in this case, the database. So this function is also not deterministic. Another common example, just like the database, you can actually access some remote API. In this case, I want to check the status of the user, and I'm using this. I'm using an API call to this address with the user ID. And if the response fails, I'm throwing an exception. Otherwise, I'm returning the status of the users that I found in the remote API. So in this case, also, my function depends on the outcome of some remote API. So I can execute this function multiple times, and I'm going to get different status. Now, another thing that you should consider, even if the status of the user does not change in the remote API. It's entirely possible that the connection, for example, to the remote API would fail. So I can execute this function multiple times, but then I'm going to get an exception. So this also makes this function non-deterministic. So as a final example, is this function deterministic? This is sometimes not very intuitive, but in this case, we want to check if some path on the file system is a directory. So just imagine that on my laptop, this is a directory, and I can go to the file system. I can remove this directory and create a file called downloads. And then this function is going to return a different outcome. So this function is also non-deterministic. So there are many sources of non-determinism. Just a few that we saw in the last couple of slides. You have time, randomness, network, file system, and database access. You have environment variables, mutable global states and variables, and so on. So non-determinism is basically everywhere. So the question is how to deal with non-determinism. So going back to our function, now that we know to identify non-determinism, we know that our function tomorrow is non-deterministic. Why? Because we are using daytime, day to day here, which is not deterministic. Today it's going to return the 22nd of February, and tomorrow it's going to return a different date. So if I execute the function tomorrow with the same arguments, I'm going to get different outcomes depending on when I executed the function. So one way to make this function deterministic is to take the non-deterministic part and yank it out. So let's see what it looks like. What if instead of calling datetime now inside the function, I'm going to accept the current date as an argument? Okay, so instead of calling datetime now inside the function, I'm going to accept the current date as an argument to the function. Now, is this function deterministic? Take a second, look at the function. Is this function now deterministic? If I'm going to execute this function tomorrow with the same value of as of, am I going to get the exact same outcome? Bear in mind, this is an argument and this is a constant value. So let's take a look. If I get today's date using datetime today, and then I execute this function tomorrow multiple times, I execute this function tomorrow multiple times with the same value of as of, I'm going to get the exact same outcome. So my function now is deterministic. So why should we care that we now have a function which is deterministic? We can now test this function much more easily. So just imagine that before we were unable to test our function in edge cases, and now it's so easy because you can just send today's date as an argument to the function and compare it against the expected result. So just to name a few examples, you can get tomorrow's date, you can get cross year, leap day, a problematic date in a non-leap year, and so on. So this is very easy to test this function out. But this was a very simple example, and I want to actually make this harder because your code is never that simple. There's always something that doesn't really fit. So I want to try and make this harder. Let's say that I have this function called process, and inside this function, I want to get the time where I started processing and the time that I finished processing. Now, for the sake of discussion, let's say that this is not just for logging. Let's say that this is actually something that you want to test. Let's say that the start and the completed at times actually has some significance for your business logic and that you actually want to control these values. Okay, so in this case, I can't really pass some date as an argument to the function because I don't know when the process is going to end, right? So injecting a value is not really viable in this case. So what can I do? the first thing that you might think about is, what if we implement this function called now, and this function will return the current date, and then we'll use the function now inside of our process function. Okay, so instead of calling datetime now inside the process function, we now move this function outside and we call this function inside the process function. Now, why is this better? Because now you can patch. You can patch the function now, and you can have full control of what this function returns, right? So just as an example, in my test, I want that the first time I call the function now, I want to return D1. And the second time, I want to return D2. And then I can execute this function. The function now is patched, and I have full control over the outcome. Remember, we saw patching before, we see it again now. So what is the advantages and disadvantages in this case of calling patch? Because we saw that it's working. We gained control over the values. We were able to test it with not a lot of work. So this works. But the problem with patching is that, first, the dependencies of my function are not clear. If someone is trying to test this function, it's not immediately clear that it needs to patch the function now in order to control the outcome of the test function. And second of all, my test now depends on implementation details of the actual function. Remember, patching actually augments the behavior of the function. And in order to test this function, I now need to know that someone, the person that implemented this function, used the function now. So this breaks the abstraction. So patching in this case is very fragile. So can we maybe change the implementation a bit and lose the patch? So previously we injected a value, but what if now, instead of injecting a value, we inject a function? Okay, so previously we injected the value as of, and then we were able to control the outcome of the function. Now we need to produce the value of now inside the function. So instead of passing the value, we can pass a function. So this is what the type looks like. We have an argument now, which is a function, a callable, that accepts no argument and returns an instance of datetime. So inside the function, we use this argument. To produce the current date. Now, why is this better? Because the function now has a proper type. So this is like a contract between the person who implemented this function and the person that is going to use it. Me, as the person who implemented this function, tells you, the caller, you need to send me a function that I can call and provide no arguments to, and this function should return the current date. And if you send this function to me, I'm going to operate as you would expect. So if we look at the tests now, this is how we can use that in our production code. If we just want to use the current date, we can pass this argument datetime now. And this would work because the function would just call datetime now to get the current date, right? But if we want to test this function, just like before, we can create a function. In this case, it's called fake now. And this function will return D1 the first time it's called and D2 the second time it's called. You can see that. And now we can, in tests, we can create this function and provide this fake function to our process. And we have full control of how the outcome looks like. And we did that without patching. Okay? So no fancy stuff. This is just passing a function to another function. So if you actually implement this pattern throughout your code, you can actually use this fake functions to test across multiple processes. So just to recap injection versus patching. And the injection approach, the dependencies are very clear. They are all typed, and you have to provide them as arguments. So it makes it very hard to make mistakes. And in the injection, this is just a parameter. So I do not have to break the abstraction, meaning the person that is using my code or the person that is testing my code does not have to know how I implemented my code in order for it to work. So, so far we identified nondeterminism and we eliminated nondeterminism in tests by injecting values and functions. And we saw why it's better because we have full control, dependencies are clearer, it's harder to make mistakes, and it's much easier to test. So, as I mentioned before, I know that in real life situations, it's rarely that simple. So I actually have another example. I don't have much time for it. I just have like 10 minutes left, but I'm going to try and go through this function very quickly, and hopefully you'll get something from it. Okay? So let's say that you want to implement integrate some IP lookup into your system. You want to find the country where a request originated from based on its IP address. Maybe you want to adjust the price. Maybe you want to log. Maybe you need to do that for security purposes. I don't know. So if you needed to implement this and you wanted to use some remote API, this is a fake one. It's not a real one. So you can try, and first you obtain the IP address from the request, and then you access this remote API. You provide it with the IP that you found, and if the response failed, you return none. Otherwise, you return the country code from the response. I'm sure that many of you used a very similar pattern in your code many, many times. It doesn't have to be a GeoIP or IP lookup. It could be something else. So let's say that you want to test this function. I'm not going to go over the entire test. I would just say that in here, we are creating a request, a fake request using the Django request factory. And then because we used requests library and we want to mock the response of this request, I mean, we don't want to make API calls in our test, so we need to mock the response. We can use this package called responses, and we open a context to patch the outcome. And we provided with the method, the URL pattern that the function is calling, the status code, the serialization format, the actual response, and only then we can actually test the function. So that's a lot of work for a very, very simple test, and that's actually not the worst part. The worst part of this test is that I had to know so many implementation details on the function just to test it. I needed to know what is the URL structure of the remote API, what type of status codes is the remote API returning, what is the serialization format. Maybe it's using XML, maybe it's using JSON. I had to know about the transport mechanism. We assumed that we are using HTTP, but we can use sockets, we can use something else. I also needed to know what the response looks like. And I needed to know all of that just to test a simple function, my logic for how I interact with the response of this API. So this is not very good because my test should not fail if some implementation details in the remote API changes. I need to create some kind of buffer, decouple these two concerns. So what you might do is you might use this pattern of an IP lookup service. Okay, so this service accepts the base URL and then implements a function that accepts the IP address and does what we've done before, right? Issues a GET request to the remote API and returns the country code. So if we want to use this service, we need to instantiate it with some base URL and execute the function, get the country. And we can now change our previous function. And now instead of issuing the request inside the function, and remember, when I issue the function, when I issue an API request inside the function, this makes my function non-deterministic, right? So we are trying to eliminate non-determinism. So this time I can inject this service called IP lookup service. And now I can call this function inside of my top level get country from request function. And that's it. I instantiate the service and then I call it like that. So if I want to test this function, what I can do is I can create a fake IP lookup service. Okay? And this fake IP lookup service is completely deterministic. I provide it with the country code that I wanted to return. And then when this fake service is called, is going to return this country code. So my tests now look very simple. I create an instance of fake IP lookup, and every time the function is called, it will return US, and I can test this function simply by injecting the fake IP lookup service. So no patching, no magic dependencies, just a different pattern, okay? And notice that now the function get country from request is not concerned at all with how I actually get the IP, the country from the IP address. So we cheated because we have a problem with the type. We used IP lookup service, but we actually injected fake IP lookup service. So if you're using MyPy, you're going to get some warning. So I'm not going to get too much into it because I don't have much time, but you could use an abstract base class, and then each implementation needs to extend this base class, and then you use the IP lookup service as type, and then you can inject each of these implementations as dependency. Now, another benefit of dependency injection is that you can actually switch implementations. So previously we used a fake IP lookup and we used a remote IP lookup, but you can actually download the entire GeoIP database to your file system, and you can implement a local IP lookup service that uses the local database file and get the code locally without even issuing any kind of network request. This package, GeoIP, I think it's bundled into Django, so you might just have it already. So if you do that, you can just create an instance of the local IP address and you can inject it to your top level function, and that's it. You switched implementation, your tests remain unchanged. The top level function should not know about this change at all, and the entire business logic is completely separate from how you get country code for your IP addresses. So I'm about almost done. So the benefits of dependency injection is it makes tests deterministic. So no surprises, no flaky tests. Everything that passed today will pass tomorrow. It's much easier to test. There's no patching. It's harder to make a mistake. We saw how by injecting different values, we get full control over the outcome. So we can test different edge cases. The dependencies are properly typed, and it's very, very clear what I'm expecting to get. And finally, we saw that we can actually switch implementations when we use dependency injection, because we can decouple the logic of in our case, the service, from how it's being used by some top-level function. So I just want to remind you that dependency injection is great, but it's not the solution to everything. This is just a pattern, and you can use it when it makes sense for your project. If you want to catch dependency injection in the wild, then PyTest, which is a very popular testing framework for Python, uses dependency injection for their fixtures system. You can just write a test, you type the name of the fixture, and PyTest will inject it for you. Fast API, which is I would say modern and very popular framework at the moment, also adopted dependency injection. And actually, the pattern that we saw before, when you can have a view function that accepts a request and then some services, is a pattern that Fast API actually uses. So if you need an evidence that dependency injection is I would say, proven approach or a proven pattern, then you can take a look at these popular and modern frameworks. And that's a great evidence and implementations of dependency injection in the wild. So if you want to know more about what I presented today, you can read the full article. It's called Stop Using Daytime Now. And you can find more information about when to inject values and how to use protocol for typings, and a bit more about how to do the refactoring. And that's it. 45 minutes. So you can check out hakibenita.com. I write about this type of stuff, about Python, databases, SQL, Django, and tuning and so on. If I have thoughts that I don't think are big enough for an article, then I tweet about them, so you can look me up on Twitter. This is my handle. And if you want to get an email when I publish something new, you can subscribe here. And finally, if you want to say to me something in person or personally, you can just send me an email to this address. This is it, I guess. I'm going to stop sharing. And let's see if we have any questions. Did I make the time?
No. So that yeah. So that comes to the end of the session. And now you can either use the Q&A chat or the raise hand option to unmute yourselves and direct your questions to clarify your doubts.
Okay, so you want me to go over some of the questions? I see someone voted. Okay, so what would be the impact to testability and maintainability? Exactly, to the code with dependency injection. So hopefully by the end of this talk, it's clear why how you can benefit, how testability can benefit from dependency injection. We saw in the first couple of examples how difficult it was to test different edge cases. And once we changed our code and introduced dependency injection, it was much easier to simulate different scenarios. And also regarding maintainability, I think that in order to improve maintainability, what you need to do is you need to make it very hard to make mistakes. So if you provide arguments and you properly type them and you avoid magic stuff like patching, in the long run, it is going to be easier to maintain the code. So the next question is how dependency injection is addressing challenges related to non-determinism. Okay, so the point of dependency injection is that whenever we have non-determinism in our function and we want to eliminate it, we yank it out. Okay, instead of, for example, in our tomorrow function, we had a call to daytime today, and this is non-deterministic. And in order to be able to test the function, we needed to take the non-deterministic part and yank it as an argument. So when you inject the non-deterministic part as an argument, the function is deterministic. So now you can test different edge cases, you gain full control over the outcome of the function. So this is how dependency injection addresses challenges related to non-determinism.
Yeah,
So when
Mr.
should I use
Benita.
dependency injection? Do I have more time? Because you have some great
Yeah,
questions.
sorry to interrupt. With the time constraint we have, we can answer for another one question, I think.
Okay. When should I use dependency injection? That's the $1,000,000 question. When should I use any pattern? I would say that dependency injection makes sense when you have a function that implements some kind of business logic and you have non-determinism inside the function that prevents you from reliably testing this function. So dependency injection has a lot of benefits. We saw, for example, that you can benefit by simply switching implementations. But from my experience, when you have a good test suite, a reliable test suite, it makes it much easier to maintain the project, introduce new developers into the project, implement new features. And a lot of that was made possible because we used dependency injection in various places to gain control over the outcomes of our functions.
Okay. Yes, there's one person has raised his hand. So
Hi, okay.
yes,
Hi.
Jason.
Yeah, and Jason. So I just want to ask a simple question now. When rolling out this dependency injection, so it seems this is Python like kind of at an early stage of it, because I have seen other languages where they push different frameworks, right? They allow you to do conditional injection, and then they make sure that there is a dependency container, and the implementations are not really aware of the container. That's part of the inversion of control requirement. Are those kind of capabilities available in Python, or is it at this level? Are there any frameworks that actually handle this and remove that boilerplate from us?
Okay, thank you, Jason. That's actually a great question. It's true that there are frameworks like PyTest, for example, Fast API, and in different languages like AngularJS back in the day, that completely adopted dependency injection as a first-class citizen. Uh, in Python, if you're looking for a framework, then I give an example like PyTest and Fast API. They provide an entire framework where you can inject dependencies based on keyword arguments and types into functions, which I think is amazing. But for example, if you're working with Django, there is no dependency injection in Django. And if you're using SQL Alchemy models and you need to inject some service into a model, then you need to do it yourself. But to that, I would say that I would start small. Okay, I would not start with a full-blown framework because it's very all-consuming. I would start small. If you have a function that needs to use the current date, then yank it out and inject a value. If you have a function that needs to perform some functionality, then yank this out and inject a function. And once you get started, I think that certain patterns will surface and you would be in a better position to decide if you want to integrate some full blown framework. I can say for myself that we just do dependency injection ourselves. We never implemented any type of framework which I can recommend on to dependency injection. Hopefully,
Thank
this
you,
answers
Haki.
the question.
Yeah, that does. Thank you.
Thank you.
Thank you, Jason, for your question. Thank you, sir. Hope that our enthusiastic Pythonistas will be great coders after grasping this knowledge. And also thank you for the active participation of you all. Next up, we have another interesting session at 2 p.m. on Enumerate from the Ground Up. See you all back again after the break.
Okay. Thank you all. Bye.